तुझे भी जीतना है सुन लो। So, hi guys, this is Varshney from Varshney channel, and you are watching currently video number 37 of Study with Step 6. This is the video number 27 of consistency, and again I'm telling you this is not just a live stream, this is a productive live stream, and update regarding to my loan is that कि अभी लोन पास नहीं हुआ है तो लैपटॉप का पता नहीं. I don't know about laptop. I think I will use this laptop in my further studies. यही मेरा साथी है आगे का. कोई नहीं. So our today target is of 3 sessions. Okay, we will continue to 3 sessions, and today we will study first microprocessors, then we will do some coding. Okay, first we will study microprocessors to start flow. Okay. So without time waste, see. Sorry. Let's start our session. तुझे भी जीतना है सुन. Let's start.
today's video, we're going to learn the data transfer group of instructions of 8085. So we're doing this whole series of 8085 instruction set. We're going to cover each and every instruction. The instruction set is divided into 5 groups. The first group is called data transfer. So this video is about the data transfer group of instructions. There are 16 instructions in that group. All the 16 instructions are there on the board. As you can understand, data transfer instruction means we are not doing any arithmetic or logic operation. We are simply transferring data from one place to the other. What are the places? You could transfer data from a register to another register, or from a register to a memory location, or from a memory location to a register, or you can put data directly into a register. I'm sure you know about the registers of 8085. 8085 has got 7 general purpose registers: A, B, C, D, E, H, L. I'm sure you've seen the architecture, you've seen addressing modes. Those are required to understand this video. Now, out of those 7 registers, B, C, D, E, and H, L can be used as pairs. When you use them as a pair, they work as a 16-bit register pair. Okay, so you can form BC pair, DE pair, and HL pair. A is a singular register, but you know, if you've seen the architecture, it's the most important register, also called the accumulator. It acts as the accumulator. It acts as the accumulator in arithmetic and logic operations. Also, there is something called M. M is not a register. Okay, M is a memory location. It can be any memory location whose address is given by HL pair. So if you say you're putting something in B register, the value will go into a register. If you say you're putting something in C register, it will go into some register. But if you say you're putting something in M, the value is not going into any register. It is going to a memory location pointed by HL pair. Whatever is the value present in HL pair, that value will act as an address. M is that location. So if you put something into M, it doesn't go into a register. It goes into a memory location whose address is given by HL pair. Of course, I'm going to teach you that in detail as we see the various instructions one by one. Okay, so we begin with our first instruction. The first instruction is called MVI. Please tell me, you've seen addressing modes, correct? Please watch addressing modes before watching this, please. Now, in addressing mode, what have I taught you? The moment you see a number, whenever in 8085, in any instruction, if you see a number, the first thing that you do is you look for an I. If there is an I, the number is data. If there is no I, the number is an address. Are you clear? So because there is 25 over here, don't jump to a conclusion. First, wait. Is there an I in the instruction? Yes. That means this number is data. It's an immediate operand. I stands for immediate. So move immediately into B register the value 25. Simplest instruction. B gets the value 25. When do you use this instruction? In the beginning of every program. Every time you write a program, you need to initialize some or the other register. So whenever you want to put any number into any register, you use the instruction MVI. Now instead of B, which register can be used? Any of the 7 registers can come over here. A, B, C, D, E, H, L. So all of the instructions work on all of the registers unless there is something specific. If there is something specific, I'll tell you. Like exchange instruction works only on HL and DE pair. Right now, don't worry. When I teach you, so if there is something specific, I'll tell you. Otherwise, everything works on every register. Okay. So MVI B, 25, B gets the value 25. As simple as that. Next one. LXI B, 2000. Now, again, you see a number. You see an I. Because there is an I, that means this number is data. Are you clear? So we are saying put the data 2000. Now 2000 is a how many bit number? 16 bit. 16 bit number cannot go into one register. It can only go into a register pair. So the instruction is not MVI. The instruction is LXI. X indicates that there is a register pair. Remember what I told you? If this is also B, I told you all of this in addressing modes. Okay. This is also B. This is also B. Now this is B register. This is BC pair. How do you know it's BC pair? Because of the X. So MVI is used when you want to put an 8-bit number into an 8-bit register. LXI is used when you want to put a 16-bit number into a 16-bit register. Please tell me, did you understand? So LXI B 2000, B means BC pair because there is an X. So BC pair gets the number 2000. When I say BC pair gets 2000, who gets what? B is the higher byte. So out of 2000, B will get 20 and C will get 00. Please tell me, are you clear? So if I write LXI D, okay, D for Delhi. LXI D, comma 1, 2, 3, 4. Who gets what? DE pair gets 1, 2, 3, 4, where D gets 1, 2 and E gets 3, 4. LXI H 4000. Who gets what? HL pair gets the value 4000. So H gets 40 and L gets 00. Are you clear? Now, so that was MVI and LXI. The next one. MVI M, 25. Now MVI M, 25. What's the difference? This was also MVI, this is also MVI. That means they both work on 8-bit data. Here, you're putting an 8-bit number. Careful. Here, you're putting an 8-bit number into an 8-bit register. Here, you're putting an 8-bit number into a memory location. M is not the 8th register. There is no register by the name M. M is not a physical quantity. Did you hear what I said? When you look at the kit of 8085, if you see the architecture of 8085, if you go inside 8085 and see, you will locate an A, a B, a C, a D. There is no M. M is not a physical quantity. M is a programming tool. M means any location pointed by HL pair. So before using this instruction, you as a programmer will first initialize HL pair. Suppose I have initialized HL pair as 4000. HL pair can be anything from 0000 to etc. Whatever is the value in HL pair, that will act as an address every time you write M. Any instruction where you written M, processor will first go to HL pair. If HL pair contains, as an example, 4000, that means your M is referring to memory location 4000. Please tell me, did you understand? It's not referring to a register, it is referring to a memory location. Here 25 goes into some register. Here 25 will go into a memory location which is pointed by HL pair. Please tell me, did you understand this? Now, let me just test you. If I write MVI M, 25, and I put this instruction in a loop. I have not taught you looping, but we can always discuss it orally. Eventually, I'll teach you looping also. Right now, let's discuss the concept. Suppose I put this instruction in a loop and I do it 10 times. And in the loop, I go on incrementing HL pair. What is going to happen? First time HL pair was 4000, so 25 comes at 4000. In the loop, I increment HL pair. Next iteration, HL pair will be 4001. That means that same 25 will go to 4001, 4002, 4003, 4004. That means you'll be able to write 25 10 memory locations. Please tell me, did you understand the point? If you want to access any memory location, you want to access location 8000. Initialize HL pair with the value 8000. How? LXI H. Yes, again, LXI H, 8000. HL pair is 8000. For HL pair, 8000 is the value. It's its data. It's the data of HL pair. Here are my words. For HL pair, 8000 is the data. For M, that 8000 will now act as an address. Whenever you write M in any instruction, processor will go to HL pair, take whatever is the value in our example 8000, go to location 8000. That location is referred to as M. If you write MBI M, 33, that location will now get the value 33. Please tell me, did you understand? As we do more instructions, we get more and more clear because I take more examples. I can take all the examples in one instruction and be information over. As we see more situations, you will understand M all the more and more clear. Anyways, I hope you understood these three instructions. So for the last time, you're putting 8-bit number into an 8-bit register, 16-bit number into a register pair, and 8-bit number into a memory location pointed by HL pair, into a memory location pointed by HL pair. Now, if you understood those three, answer the next three by yourself. Come on. Move B, C. Who gets what? B gets the value of C. Again. Okay. So next one. Move B, C. B gets the value of C. I repeat. B register gets the value of C register. When people look at this instruction, they get confused. Is B getting the value of C or is C getting the value of B? Don't get confused. In any language, if you write B is equal to C, who gets what? You tell me, who gets what? B gets the value of C. Am I right or no? So B is your destination, C is your source. In every language in the world, first you write your destination, then you write your source. Similarly over here, move B, C, it is basically destination, source. The value will be copied from C register into B register. It will not be cut, it will be copied. You understand the difference, right? If C was 33, D will also become 33, but that 33 will remain in C. C will not become blank or will not get a random value. That 33 will remain in C and will be copied into B register. Are you clear? So this instruction is used when you want to copy the value from one register to another register. Move B, M. Are they both the same instructions? No. When you learn timing diagrams, you come to know this is 40 states, this is 70 states. Here the operation is from a register to a register. Here B is getting the data from, say it now, you say it, I'm not going to say it, you say it. B is getting the data from M. What is M? A memory location. Shabash, very good. A memory location pointed by HL pair. So B will get the data from some memory location. Here B is getting the data from some register. And lastly, move M, C. The value of C register will be stored into a memory location. Let's do all the three with the help of a diagram. You'll understand it much better. And I want answers from you. Come on. This is your MUP. Inside the MUP, all 7 registers are there. So I've shown you B register, C register. B has the value 20, C has the value 30, HL pair has the value 4000. I've just given random values. They all valid examples, correct? 8-bit, 8-bit, and 16-bit. Fine. This is the memory. In the memory, there are locations. There is some location 4000. Because HL pair is 4000, the value of location 4000 is what is called M. M refers to the memory location pointed by HL pair, correct? So as of now, what is M? 15. Does M exist? No. Whenever you write M, processor will go to location 4000 and from there will work on this number 15. Please tell me, did you understand this? So tell me all the three instructions. Move B, C. B gets the value of C. What does that mean? B gets the value of C. So C is 30, so B will become 30. Please tell me, did you understand? It will remain in C also and be copied into B. Are you clear? Next, move B, M. B will get the value of M. Now the moment processor sees M, first of all it goes to HL pair. What is the number in HL pair? 4000. We'll use 4000 as an address. In that location, the data is 15. The value 15 will come into B. So B will get the value of 15. Please tell me, did you understand this? Is this clear? Move B, C. B gets the value of C. Move B, M. B gets the value of memory location. Did you understand it? Move M, C. Come on, answer this one by yourself. M gets the value of C. M gets the value of C. So M gets the value of C means this is M. This is your memory location. M, it will get the value of C. Whenever you say write M in any instruction, processor goes to HL pair. In HL pair is 4000. You go to location 4000. This is M. Move M, C means you are saying M wants the value of C register. So the value 30 will now come into this location. Please tell me, did you understand? We'll overwrite 15 and 30 will come into this location as the new value of this location. Is that clear? So as you can see, what are we doing in all these instructions? Are we doing any add subtract? No, these are just transferring data. That's why the group is called data transfer group. I repeat, data transfer group. It is transferring data from one place to the other. Now, the next one. Come on. Yeah, a little more intricate, so I need a little more concentration from you. Okay? LDA 2000. Come on, we've learned this. In addressing modes, we've learned this. LDA 2000. Again, you see a number 2000. Don't jump to a conclusion. 2000 could have been an address, could have been a data. What is 2000 in this case? Do you see a number? Do you see an I anywhere over here? No. Since there is no I, that means this 2000 is not data. This 2000 is an address. First of all, tell me, did you understand this? Look here. This is also 2000. Look here. This is also 2000. In this instruction, there is an I. That means this 2000 is data. In this instruction, there is no I. That means this 2000 is an address. Are you understanding this? So LDA 2000. Load directly into A register the contents of location 2000. Load into A the contents of location 2000. When you see LDA, what does LDA stand for? Load A. Load means put. Put into A. So at least you understand who is getting the value A. Now you see 2000. Is A getting 2000? Come on, you don't need somebody to teach you so much. You understand by common sense. 2000 is 16-bit number. How can 2000 ever fit in A register? So isn't that obvious that this 2000 is not data? This 2000 is an address. So load into A the contents of location 2000. If you want, you can write like this: contents of location 2000. That is also fine. Otherwise, if you want to write it in notation, you want to be a fast writer. This is the textbook you are writing. Every textbook uses it. The moment you put square brackets are read as contents of. So A gets the contents of location 2000. Please tell me, did you understand? Contents of the memory location 2000. This is clear. So this is memory location 2000. This is A register. When you write LDA 2000, whatever is there at 2000, what is there? 53. Can you see? This 53 will come into A register. A will now become 53. Please tell me, did you understand this? Come on, one. Come on, pick up pace now. STA 3000. What is STA? Store A. Now A will not get the value. Now A will send the value. A will be stored at the location 3000. Do you understand? It's the exact opposite instruction. So here the value of A will be stored at the memory location 6000. So this 69 will be replaced with the number 53. A had the value 53. That 53 will be stored at location 3000. So once again for the last time, LDA 2000, A gets the contents of location 2000. STA 3000, A will be stored as the contents of location 3000. Are you clear? You're taking data from a memory location, you're storing data into a memory location. Both of them are using direct addressing mode. Why are they using direct addressing mode? Because both the instructions carry an address. Whenever address is given in the instruction, it's called direct addressing. Let's go through the addressing of the other instruction. Here data is there in the instruction. If data is there in the instruction, it's called immediate addressing. Data is given by a register, so it's called register addressing. Address is given in the instruction, so it's called direct addressing. I'm not addressing modes. I'm just doing this for the sake of understanding. Of course, you all know addressing modes properly. Please watch the addressing mode video. You should be watching that before you watch this. Anyway. Now, superb instruction from as a direct question by itself. From timing diagram point of view also. It has a very big timing diagram, 16 states timing diagram. Yeah, 16 states timing diagram. 4, 3, 3, 3, 3. When we draw timing diagram, we come to know. Anyway. So the instruction is LHLD 5000. LHLD stands for load HL pair directly. Again, load HL pair directly. So you're loading HL pair. Load HL pair means who is getting a value? HL pair. You understand? There is a number. What is the key thing I told you in the beginning of the video? Whenever you see a number, don't jump to a conclusion. Means how many bits data you want? 16 bit. I don't do guesswork and I don't expect you to do guesswork. There is a sound logic how this is happening. Get the logic. I've told this to you before also in some of the other videos. There is a principle followed called little endian rule. Intel processors use this principle. Look, most processors use. Some don't. There are exceptions to every rule, but not in your subject. Your 1885 always follows this rule. The rule is called little endian rule. It says lower byte is always at the lower address, higher byte is always at the higher address. Say it again. Lower byte, lower address, higher byte, higher address. Now, you have location 5000 and 5001. You understand these are two addresses. The smaller address is 5000, the bigger address is 5001, which is obvious. It's a smaller number. So this means this is the lower address. It will give the lower byte. 5001 will give the higher byte. Please tell me, did you understand? So that's how N gets the data from 5000 and H gets the data from 5001. 5000's data is 84, 5001's data is 15. So that means L will get the value 84, H will get the value 15, which means HL pair will now get the value 1584. Did you understand this? If you had the number 1584 and you want to put it into HL pair, you write LXI H 1584. But here you don't have the number with you. Many times you don't have the data with you. The data is stored in the memory location. If you want to obtain data from a memory location, if you want to obtain 8-bit data from a memory location, you use LDA. If you want to obtain 16-bit data from a memory location, you use LHLD. LHLD 5000 as an example will get you data from 5000 and 5001. Please tell me, did you understand? I'm spending so much time on these instructions because I know what this subject is all about. You're starting to learn this subject. I've been teaching this subject since 18 years. If I'm spending so much time on this instruction, please understand it's important from programming point of view. There are situations when you want to directly grab 16-bit data from the memory. Whenever you want to do that, remember 16-bit data will not be stored in one register, will require a register pair. Moreover, it will come from two locations. So the perfect instruction to directly grab 16-bit data from the memory is LHLD. And now the reverse instruction, SHLD. SHLD stands for stored HL pair. I repeat, stored, come on, answer by yourself. Stored HL pair at so and so location. Now you tell me, HL pair is how many bits? 16 bits. So will it be stored at one location or two locations? Two locations. Do you have the lower location 1, 2, 3, 4 and X modes. Indirect addressing mode. Come on. LDAXB. Answer this one. If you can answer this one by yourself, you cross the bridge. Come on, now then you understood everything I'm talking. LDAXB. Now when you say LDA, what do you understand? LDA stands for load A. That means who is getting the data? A. You clear about it? Who's getting the data? A. Now, you see a B over here. So what? Is A getting the value of B? No, we're not stupid. If A had to get the value of B, come on, look here. If A had to get the value of B, what instruction will you write? You want A to get the value of B. Come on, say it. The more you say it, the better you get. I want A to get the value of B. What instruction will you write? Correct. You'll be writing move A, comma B. A will get the value of B. So here we are writing something else. That means A is not getting the value of B. It's far more than this. Look here. There is an X in the instruction. Is that X just like that? No. That X indicates that there is a register pair involved. Are you clear? Learn to understand instructions the right way. These alphabets are there for a reason. So that the programmer can understand what he or she is learning. So that X indicates that it's a register pair. That means this is not B. It is BC pair. So I say again. I want A to get the value from BC pair, but that is ridiculous. A cannot get the value of BC pair. BC pair is 16-bit. A is only 8-bit. BC pair will give an address. Say again. BC pair will give an address. A will get the data from the location pointed by BC pair. Did you understand this? Come on, I'll make you understand. That's my job. But I want your attention. This is A, this is B, this is C, this is the memory. Suppose B is 1, 2. Okay, I hope you can see this clearly. B is 1, 2, C is 3, 4. So what is BC pair right now? 1, 2, 3, 4. Correct? I'm saying LDAXP. A should get the data pointed by BC pair. What does that mean? Processor will go to BC pair. Now, is A getting 1, 2? No. Is A getting 3, 4? No. Is A getting 1, 2, 3, 4? No. Impossible. How can A get 1, 2, 3, 4? 1, 2, 3, 4 will act as an address. A will get the data from the memory location pointed by BC pair. BC pair is just used to give an address for the operation. Are you clear? This is called indirect addressing, where address is given using registers. Come on, look here. When I write LDA 2000, who gets what? A gets the data from location 2000. So if I wanted data from location 1234, I could have written LDA 1234. A will still get the data from 1234. I agree. If that is a question in your mind, you and I are exactly at the same place. Because this is a question that will come to anybody's mind at this point of time. A should, if I want A to get the data of 1234, I can simply write LDA 1234. Yes, you can, but then you cannot put that in a loop. This is good when you want data from one location. If I want data from 100 locations, one by one, I want data from 100 locations. How can you do this? You're not going to write LDA 2000, LDA 2000, LDA 2000, LDA 2003. Then what you want to do is put 2000 into some register pair and write, let's say, BC pair and write LDHB. Put this instruction in a loop, and in the loop, go on implementing BC pair. As you go on implementing BC pair, every time BC pair will point to a new location, and you will get the data from that location. I hope you understood my point. Okay, I've explained this in addressing modes, but sometimes students probably last day just realize, okay, let's become serious right at the end. Then they don't have the time to watch all the videos in the correct order. Even the class when I explain, I do explain this point again, so maybe somebody just missed addressing mode lecture, and the person should not feel completely lost. If you've seen addressing modes video, I explained this in more detail with more examples. I don't want to follow over it again, because then we'll just be doing the same point, not learning more. There's still many more instructions to go. But I hope you understood my point. So, then the next instruction by yourself. Come on. Absolutely clear answer I want, no confusion. STAXT. When you see STA, what do you understand? Store A. You're going to store the value of A somewhere. Are you clear? You see a T. That means you want to store the value of A into D. No. Because there is an X. X means DE pair. So are you going to store the value of A into DE pair? No, even that is not possible. How can you store the value of A into DE pair? This is D, this is D. DE pair is 16-bit. A is 8-bit. Suppose D was 40 and T is 00. DE pair is right now 4000. You're not storing A in D, you're not storing A in D, you're not storing A in DE pair. DE pair collectively will now act as an address. Processor will go to location 4000. A will be stored at the location 4000. You're not storing it into DE pair. DE pair is used to give the address. Store A at the memory location pointed by DE pair. What is the advantage of this instruction? Put this in a loop and go on implementing DE pair. Every time A will be stored at a different location. Please tell me, did you understand? Is the use of LDXD and STXD clear? Again, this would have been BC pair or DE pair, this would have been BC pair or DE pair. These would not be HL pair. Why? There is a reason for that later, not right now. Too early to know that. But you got the point. Anyways, you understand you can use BC pair over here or DE pair, similarly BC pair or DE pair. Now, so what do these instructions do? They are used to take data from the memory and store data into the memory, and they are indirect addressing mode, so they are best useful when you want to put them into a loop. Suppose I tell you write a program to transfer a block of data from 2000 to 3000. You will initialize BC pair with 2000, the DE pair with 3000, LDAXB data will come here, STXD data will be stored here, increment BC pair, increment DE pair, put it in a loop. That becomes your block transfer program. I'll be doing the program. I'm not teaching the program, I can teach everything in one lecture. I'll be doing the program for this. That time you see it more clearly. I'm just planting the seed in your mind that this is used for doing block transfers. Typical instruction used for block transfer. Now the next two instructions are very simple on face value. They have bigger repercussions in theory topics, but on face value they're very simple. Even timing diagram very simple. 1 of 4, 6 equates. PCHL, PC gets the value of HL. SPHL, SP gets the value of HL. Let's understand them properly. PCHL, what is PC? Program counter. What does it contain? Address of the next instruction. I hope you remember PC register. Goes on getting incremented automatically. Now PCHL, PC will simply get the value of HL. Totally let it put it simple. You will initialize BC pair with 2000, so DE pair with 3000, LDEXB program. Too early to know that, but you got the point. Anyways, you understand you can use BC pair over here or DE pair, similarly BC pair or DE pair. Now, so what do these instructions do? They are used to take data from the memory and store data into the memory, and they are indirect addressing mode, so they are best useful when you want to put them into a loop. Suppose I tell you write a program to transfer a block of data from 2000 to 3000. You will initialize BC pair with 2000, the DE pair with 3000, LDEXB data will come here, STXD data will be stored here, increment BC pair, increment DE pair, put it in a loop. That becomes your block transfer program. I'll be doing the program. I'm not teaching the program, I can teach everything in one lecture. I'll be doing the program for this. That time you'll see it more clearly. I'm just planting the seed in your mind that this is used for doing block transfers. Typical instruction used for block transfers. Now the next two instructions are very simple on face value. They have bigger repercussions in theory topics, but on face value they're very simple instructions. Even timing diagram very simple. 1 of 4, 6 equates. PCHL, PC gets the value of HL. SPHL, SP gets the value of HL. Let's understand them properly. PCHL, what is PC? Program counter. What does it contain? Address of the next instruction. I hope you remember PC register. Goes on getting incremented automatically. Now PCHL, PC will simply get the value of HL. Totally legit justified operation. HL is 16-bit, PC is 16-bit, PC will get the value of HL. As simple as that. SPHL, again the same thing. SP is also a 16-bit register. We get the value of HL there. Simple. On the face value, the very simple instructions. They both have very interesting uses. But as I said, I cannot show you everything in one hand. Right now, we're learning instructions. Whichever ones have a direct use, I'm telling you. The ones which have very intricate uses, for that you have to learn some topics to understand them. But it will come. Eventually, it will come. It will be there in the course of all the videos. You'll be seeing the use of these instructions. Not very important from exam point of view, but quite interesting from understanding point of view. But the time will come when you suddenly come back to these instructions again. I'll suddenly tell you, remember the instruction number 13 of group number 1. And that time you should remember there's PCHL. There's something that PCHL does, which is very crazy, but this is not the time for it. So here I just told you what these instructions do. PC gets the value of HL, SP gets the value of HL. The next one, XCHG. Exchange HL pair and DE pair. This is HL pair, this is DE pair. What we're doing is interchanging the value of HL pair and DE pair. How will that happen? First processor will take the value of DE pair into a temporary register like WZ. I hope you remember there's a WZ pair. We'll take the value of HL into DE, we'll transfer the value of WZ into HL. Can even do it the other way around. The point is both of them have to be exchanged. So internally it's done using WZ. So this is HL pair, this is DE pair. One of the values will be taken into WZ, the other value in the first register, and then WZ will put the value in the second register. So the values will be interchanged. Suppose we have 1, 2, 3, 4, and 5, 6, 7, 8. First 5, 6, 7, 8 will come here, 1, 2, 3, 4 will come here, 5, 6, 7, 8 will come here. So eventually both of them will be exchanged. The point to remember over here is exchange instruction in 8085 is designed to work only on HL pair and DE pair. Okay, it will not work on any other pair, it will only work on HL pair and DE pair. That's why you're not allowed to write any register. The name of the instruction is simple exchange. You cannot specify the register. It is implied it is only going to exchange the value of HL pair and DE pair. Are you clear? The last instruction of this group, XTHL, surprising instruction. People who do guesswork can never figure out what this instruction is. Let's first see the full form. XTHL stands for exchange top with HL. I repeat, exchange top with HL. What top? Top of stack. You know there is a stack. The most important element of the stack is the top of stack. You want to exchange that top of stack with HL. Now, who points to the top of stack? SP, that is stack pointer. You know these things, right? The stack is somewhere in the memory. This is the stack. The top of stack's address is given by SP. SP points to the top of stack. So many students think, oh, that means in this instruction we are exchanging the value of HL with the value of SP. No. SP is stack pointer. Okay. SP gives the address of top of stack. SP is just giving this address. We are not exchanging HL pair with this address. We are exchanging HL pair with the data stored at the top of stack. I have given more clear diagrams over here, bigger diagrams. Please pay attention. Come on, look here. This is the memory. This is your stack. These are all the elements. This is the top of stack. 34 is the topmost element of the stack pointed by SP. What does SP give? This address. I am not interested in that address. I am interested in the data stored in the top of stack. I want to exchange HL pair with this data. Now, HL pair is how many bits? 16 bits. Pay attention, okay? It's one of the trickiest timing diagrams. One of the trickiest timing diagrams, okay? I want to exchange this data with HL pair. HL pair is how many bits? 16 bits. 16 bits means it cannot be exchanged with one location. It will require two locations for exchange because one location always carries one byte. Okay, this is the 5th time I'm saying this in this video. So, this is 8-bit data, this is 8-bit data. Together, this is 16-bit data. This whole data will be exchanged with HL pair. So, HL pair will be exchanged with the data pointed, location pointed by SP and SP plus 1. Now, who will be exchanged with what? This address is SP, this address is SP plus 1. What is the rule I have told you? Lower byte, lower address, higher byte, higher address. This is the lower address, this is the higher address, this will be exchanged with the lower byte, this will be exchanged with the higher byte. Are you clear? How does an exchange happen? Using WZ register. So this exchange will be supported by Z, this exchange will be supported by W. Now, I could finish over here, but I am giving you a more detailed picture because, as I said, this is one of the trickiest timing diagrams to learn. So, understand this operation properly. This is the top of stack, this is the next element. I want to exchange this data with the value of HL. Suppose HL pair right now contains 5, 6, 7, 8 and top of stack contains 1, 2, 3, 4. Picture clear? After the operation, this should be 5, 6, 7, 8 and this should be 1, 2, 3, 4. How will the MUP do it? It will first take the data from the top two elements of the stack into WZ. This is operation 1. Of course, it will happen one by one. 2 memory reads will be required. That happens in timing diagrams. I am not putting everything in one video. But understand, just showing you the operation. It will take the data from top two elements of the stack into W and Z. So they have acquired the numbers 1, 2 and 3, 4. Then once it has got this data, it will put the value of HL down over here. First H will go, then L will go into operations. I am putting this together as the second step. This was the first step, this is the second step. If you're learning timing diagrams, these are 2 memory reads and these are 2 memory writes. Okay, so opcode fetch, memory read, memory write is the sequence. So very big timing diagram. Anyway, so take this data into WZ, put the value of HL over here. When you put the value of HL over here, over here you will get 5, 6, over here you will get 7, 8. Once this is done, transfer the data from WZ into HL. WZ into HL means H will now get the value 1, 2 and L will get the value 3, 4. Is this clear? Come on, show me over here. Show me in my hand gestures. These are stack elements. Split one. Value of HL exchange. We'll interchange the value of HL pair and DE pair. NXTHL, exchange the top of stack with it. Hello people, I'm Bharat. Welcome to a new video. So in today's video, we're going to learn instruction set of 8085, 8085 microprocessor. We've already seen the first group of instructions in the previous video, that was data transfer group. This video, we're going to learn arithmetic instructions. Okay. In data transfer instructions, you are just transferring data from one place to the other. Now you're doing serious arithmetic operations. Now 8085 has these arithmetic instructions. First, we're going to see the most simplest instruction, add with a register, add with a memory location, add with immediate data. And same thing with subtract, subtract with a register, etc. Then the little more powerful one, add with carry. There is a specific place where you use add with carry. So I'm going to show you with an example how to use it. Then again add with carry with the memory location with immediate data. The same goes with subtract with borrow. Just like you use add with carry in a specific place, so do you do with subtract with borrow. So I'm going to be teaching you that with example. Then increment, decrement are very simple instructions, but there's a huge difference between increment D and increment M. Increment D increments the register. increment M, yeah, if you know what M is, it does something entirely different. So I'll be teaching you that again with a diagram with examples. Then DAD stands for double addition. That's your 16-bit addition instruction. And then finally, one of my favorite instructions is there in every processor and does the same thing, but it is so important. That's the reason why it's there in every processor. So I'll be teaching you DAA with umpteen number of examples. Okay, one of the most frequently asked questions of 8085 in terms of instructions is DAA. DAA, call, RIM, SIM. These are the big instructions of 8085. So as in when we learn them, we're going to see most examples of them. So anyways, I'll be teaching you DA with various examples. Now, okay. So our first arithmetic instruction, the simplest arithmetic instruction, add. Now when you write add, you are allowed to write only one operand next to it, one register in this case. So you write add B. Now it is obvious you don't add one number, so there has to be an operand. That operand is the accumulator. I've explained this way back in 8085 architecture itself. 8085 is an accumulator based processor. So all arithmetic logic operations, at least most of them, are working on A register as a default operand. So when you write add B, the operation is A plus B, the value of A register and B register will be added and the result will be stored in A register. Okay. Now a few things to understand from here, fine points. Okay. A and B both are 8-bit registers. When you add two 8-bit registers, you are expecting the answer to come in A, which means you're expecting the answer to be an 8-bit answer, which it will be. When you add two 8-bit numbers, the answer is 8 bits, but sometimes it can be more than 8 bits. How many bits? 16 bits? No, it can never be 16 bits. At the most, it can be 9 bits. The 9th bit is called a carry, which can only be a 0 or a 1. First of all, get this clear. Carry can never be 2. Okay, I'll prove it to you. 9 plus 9 can never be 20. 99 plus 99 can never be 200. When you add two similar size numbers, the answer is of the same size plus a carry, which can only be a 0 or a 1. Now A and B both are 8-bit registers. So what is their maximum possible value? Their biggest value is FF. Do you understand that? Now FF plus FF, that's the worst case that you can give. FF plus FF is 1FE. Just like 99 plus 99 is 198. Similarly, in hexadecimal, FF plus FF gives you 1FE. Now if the answer is 1FE, A will contain FE and the 1 will be in carry flag. Okay, so all I'm trying to say is when you get an add program, a program to add two numbers, don't just check A for the result. The answer is not only in A, it is in A and carry flag. Suppose you did FE plus 0, answer is still FE, A will still be FE, but this time carry flag will be 0. So please remember to check the carry. If you don't, you will lose marks because it's an incomplete answer then. Please tell me, are we clear? So that was your add register. Now add M. I'm sure by now you know what is M. M is the data of a memory location pointed by HL pair. When you write add M, processor first goes to HL pair. HL pair will have a 16-bit value. Let's say the value is 1, 2, 3, 4. Processor will go to location 1, 2, 3, 4. From there, whatever data it gets, it will take that data, add it to A and put the result in A. Please tell me, are you clear? Now, ADI. They add M. I'm sure by now you know what is M. M is the data of a memory location pointed by HL pair. When you write add M, processor first goes to HL pair. HL pair will have a 16-bit value. Let's say the value is 1, 2, 3, 4. Processor will go to location 1, 2, 3, 4. From there, whatever data it gets, it will take that data, add it to A and put the result in A. Please tell me, are you clear? Now, ADI. This was add. Then why is this ADI? Long time back I have given you this rule. In 8085, whenever you see a number, if that number is data, there will be an I in the instruction. The I is used to indicate immediate addressing mode. I stands for immediate addressing. So it's pronounced as add immediately the value 25. It will add the immediate number 25 to A register and will store the result in A register. Please tell me, are you clear? So these were the three types of add. Add with a register, add with a memory location, and add immediate data. Are we clear? Now exactly the same three things in subtract. Nothing to explain, it's the same thing. Subtract B, it will do A minus B. Just one small point over here to understand. When you do A minus B, if A is greater than B, great. If A is equal to B, great. If A is less than B, Do you understand the subtraction is not possible unless we take a borrow? You understand that, right? So the processor will do the subtraction but will take a borrow. To indicate that it has taken a borrow, it will make carry flag 1. Get this clear. In addition, carry flag indicates a carry. In subtraction, carry flag indicates a borrow. There is no separate borrow flag. Borrow is also stored in carry flag. So again, the point I am trying to make here is, after the operation, don't check only A. Check A and carry flag. A for the result and carry flag to know whether there was a borrow in this operation or not. Are you clear? Even when we learn compare instruction, we will know. To know whether some number is greater or smaller, we simply use subtraction. If there was a borrow, that means the first number was smaller. So again, over there we will be checking the carry flag. So carry flag plays a role even in subtraction, not just in addition. Subtract M, same thing. Instead of subtracting the value of a register, you're subtracting the contents of a memory location pointed by HLN. Subtract immediately. Now again, pay attention to the name of the instruction. It is SUI. SUI stands for subtract immediately. So it will subtract immediately the value 25 from A register and will store the result in A. So it is A minus B, A minus M and A minus 25. Please tell me, are these clear? These are very basic instructions. And I'm sure you're not watching this video. Simply incrementing the register. Basic instructions. I'm sure you're not watching this video for these instructions. You're watching it for the bigger ones. But still, I wanted you to know about the carry flag part because that plays a role. Addition, carry flag indicates a carry. In subtraction, carry flag indicates a borrow. There is no separate borrow flag. Borrow is also stored in carry flag. So again, the point I'm trying to make here is, after the operation, don't check only A. Check A and carry flag. A for the result and carry flag to know whether there was a borrow in this operation or not. Are you clear? Even when we learn compare instruction, we will know. To know whether some number is greater or smaller, we simply use subtraction. If there was a borrow, that means the first number was smaller. So again, over there, we'll be checking the carry flag. So carry flag plays a role even in subtraction, not just in addition. Subtract M, same thing. Instead of subtracting the value of a register, you're subtracting the contents of a memory location pointed by HLN. Subtract immediately. Now again, pay attention to the name of the instruction. It is SUI. SUI stands for subtract immediately. So it will subtract immediately the value 25 from A register and will store the result in A. So it is A minus B, A minus M and A minus 25. Please tell me, are these clear? These are very basic instructions. And I'm sure you're not watching this video for these instructions. You're watching it for the bigger ones. But still, I wanted you to know about the carry flag part because that plays a role when you do programs. Even when we'll be doing, so eager to start programming with you, but that is after instruction. So when we do programs, you'll understand why servers. So carry flag plays a role even in subtraction, not just in addition. Subtract M, same thing. Instead of subtracting the value of a register, you're subtracting the contents of a memory location pointed by HLN. Subtract immediately. Now again, pay attention to the name of the instruction. It is SUI. SUI stands for subtract immediately. So it will subtract immediately the value 25 from A register and will store the result in A. So it is A minus B, A minus M and A minus 25. Please tell me, are these clear? These are very basic instructions. And I'm sure you're not watching this video for these instructions. You want for the bigger one. But still, I wanted you to know about the carry flag part because that plays a role when you do programs. Even when we'll be doing, so eager to start programming with you, but that is after instruction. So when we do programs, you'll understand why servers. subtract M, same thing. Instead of subtracting the value of ADC, is add with a carry. Basic instructions. And I'm sure you're not watching this video for these instructions. You're watching it for the bigger ones. But still, I wanted you to know about the carry flag or the carry. ADC is add. The next instruction, superb instruction, ADC. What is ADC? Add with a carry. Okay, ADD is simple add. ADC is add with a carry. So here we are doing ADC B. A will get the result of A plus B. Now this much is the same as your add instruction plus the carry flag. A plus B plus carry flag. Now carry flag is a single bit, so it can be a 0 or a 1. You understand that? Now what is this carry? Is this the carry before this instruction took place, or is this the carry after adding A and B? You tell me, what do you think? This is which carry? The carry of the previous operation or the carry of this operation? 100% this is the carry of the previous operation. How can it be the carry of this operation? That is absurd. If you add two numbers, you get a sum and a carry. How do you add the carry back to the sum? It makes no sense. 9 plus 4 is 13. What does that mean? 3 and a carry 1. You don't add that 1 to 3 and make it 4. It is absurd if you do that. We are not learning absurd stuff. We are learning stuff which is tremendously logical. So you got to think better than that. This is not the carry of this operation. Certainly not. It would have made no sense that way. This is the carry of the previous operation. The addition that you have done before this operation had produced a carry. You are incorporating, you are including that carry into your result. So the question that is there in your mind right now is, why would we want to include the carry of the previous addition? In the sense, when do we use this instruction? That's what I'm going to teach you. Come on, look here. Suppose I have a number 12FF. Please answer correctly. 12FF is a how many bit number? Yes, 16 bit. You understand that, right? You can't learn big topics without having your basics clear. Please watch the introduction video. I have spent ample time to make you understand what is 8 bit and what is 16 bit. You need all that background clear. So 12FF is a 16 bit number. FF is the lower byte, 12 is the higher byte, 8 and 8, 16 bits, correct? 0001 also a 16 bit number. So both of them are 16 bit numbers. So you want to add two 16-bit numbers. Now problem is 8085 is an 8-bit processor, so it adds 8-bit numbers. So if you want to add 16-bit numbers, what do? First, let's add them. First, let's add them on paper and then we come into the program. F plus 1. F plus 1 is 0 carry 1. F plus 1 again, you know that, right? F plus 1 is 0 carry 1. So F plus 1 again is 0 carry 1. 2 plus 1 is 3 and this is 1. So 12FF plus 1 is 1300, which is so obvious. 1299 plus 1 is 1300 in decimal. Same thing, treat F as 9 whenever you come.
Yeah, we can use as such. It's break time. So yeah, we have completed one session completely. 1 out of 3 sessions. It's good. Abraham did. Okay. It's break time. Let's take it and stuff out firstly. Break time is over, I think. Let me put to this. Okay. Might. I think we should divide our time. Let's start our session and we will do Linux programming in this session. For sure, we will do Linux programming. Okay, so let us try.
अच्छा एक चीज पूछना था, आप अपना जितना भी ट्रैवल करते हैं सबसे घूमे हैं वो सब फाइनेंस आप यूट्यूब से कर लेते हैं?
अभी तो यूट्यूब से करता हूँ। शुरुआती समय में कैसे मैनेज करते हो आप? दूसरा अगर पता था खर्चे हो ही नहीं थे। अभी भी अगर खर्चा नहीं होगा, अगर मैं लैंड ट्रेवल में जो मेन एक्सपेंस था वो फ्लाइट ही होता था। मैं बता रहा हूँ, मैं फ्लाई कर रहा था सर्बिया से तंजानिया, मुझे 40 हजार। तंजानिया से मैंने फ्लाई किया था, मैं केन्या फ्लाइट किया था बाजू साइड से, और केन्या से फ्लाई किया मैं दुबई 20 हजार की फ्लाइट, दुबई से 20 हजार की फ्लाइट। हाँ, तो बड़ी फ्लाइट महंगी आती है भाई, तो मुझे
मतलब मैं मतलब फ्लाइट ही महंगा पड़ जाता है तो सस्ता आपको घूमना पड़ जाता है ना?
यही होता है। हाँ सर, थोड़ी मोटी छोटी लगती है ऐसा।
अच्छा, अभी ईरान जा रहे हैं तो सारा फाइनेंस आपका यूट्यूब से हो जा रहा है ना?
हाँ, इराक का 10 महंगा था मुझे लगा, मैंने पे किया वीजा के लिए ट्रिप दिया था काफी वीजा।
तो अभी कैसा चल रहा है इनकम इससे?
ठीक चल रहा है,
आप मतलब डाइट बता सकते हैं या?
मतलब आराम से जाता रहा हूँ। अच्छा ठीक है, अच्छा क्लियर ऐसा होता है ना कि ऊपर नीचे होते रहता है, कोई इंसान बोलने के बाद एक जगह
एवरेज एवरेज
मान लीजिए मैं बोल रहा हूँ तो ऊपर ही ना आ नहीं रहा है, सही बात है।
हाँ, सबसे हाई कहाँ था?
मैक्सिमम 1 महीने आई थिंक 6 लाख हो जाएगा
एक महीना का सिर्फ एडसेंस ना? अदर कुछ कम नहीं?
इसमें मैं ज़्यादा एड वो लेता ही नहीं
वो प्रमोशन नहीं?
सारी क्लियर के लिए इन्होंने कितना 1.5 लाख रुपये दिया था, जहाँ मेरा मन ही नहीं करता तो
मतलब
अब मुझे मतलब मुझे पसंद है कि वीडियो बनाऊँ, मज़ा नहीं आएगा।
आप मतलब एक्सप्लोरर, एक्सप्लोरर होता है, एक्सप्लोरर होता है तो एक्सप्लोरर में आ जाता है वन वन से। आप कभी भी सोचे हैं कि जाने की लद्दाख लद्दाख बाइक से ऑफ रोडिंग ऑफ रोडिंग?
पहला ट्रिप लद्दाख गई नहीं, लाइफ बनवाना पड़ेगा जाके। मैं 18 साल पहले नहीं छूट गया था, अब बनवाना पड़ेगा लाइफ टाइम।
ब्लॉग को ऐसे कर ही लिया जा सकता है नहीं मतलब? हाँ, तो आप नहीं जानते हैं तो जैसे कि घूमने फिरने का हमको बहुत है, मतलब एक्सप्लोर कर कहीं भी जाते हैं तो छोटा सा जगह जाते हैं एक्सप्लोर करने खूब मन करता है, तो क्या मैं उसको एज अ ले सकता हूँ करियर बना के? जैसे नोमैडिक इंजीनियर था तो ये करियर ले लिया ना?
मैं उतना भी सोचा नहीं उस चीज़ को।
तो आप उसको क्या कर रहे हैं फिर? और ऐसे
आज 1.5 साल पहले सब कुछ छोड़ दिया था मैंने, उसमें तो यूट्यूब भी नहीं करता था, लेकिन मैं तो जैसे कि छोटे मोटे 10-12 हज़ार महीने के आ गए, तो वो क्या उसमें ट्रैवलिंग हो गया।
तो फैमिली बिजनेस है क्या? आप मीडियम मिडिल क्लास से बिलोंग करते हैं?
हमने कोई बिजनेस करना है लेकिन पापा का साथ मना कर दिया।
तो घर बैठ के सोचते तो लगता है कि बाहर जाके घूमना बहुत ही महंगा पड़ता है।
इंडिया सब कुछ होता है,
इंडिया तो घूम ही रहे हैं। वो नहीं लगता कि टाइम बाद आप फिर अगर पूरा दुनिया बना लीजिएगा पता नहीं और नहीं था तो मेरे को ऊपर काफी सारे लोग दुनिया में अगर रहेंगे तो उनके पास इसका कोऑर्डिनेशन करने के लिए प्रयास करते हैं
Okay, so Krishna, are you here? We have completed successfully 2 sessions. It's break time. ऐसे ही नीचे ना। Sorry. Hmm. Slowly when I return I. So we have completed two session already, and I want to say that yeah, that's good. One session remaining, and it's too not too freeze cold outside. I think the weather is good as compared to tomorrow, as compared to yesterday and day before yesterday. In yesterday, the fog is too much, I can't even to can't in, unable. I'm unable to see my boundary even. So that's I think 8 feet gap. Okay, I think yeah. So I'm unable to. Also, I am able to see 8 feet gap things. It's okay, okay, okay. Still, it's good. It's all good. Kurukshetra Singh, hello sir, big fan. Say you are two officers. First of all, don't call me sir. I am your friend, dost, bhai, not a sir. I'm just a student who's trying to study in his academics, trying to score a good marks and want to improve skills. I'm just only that student, that bhala manus. So you can say that. Not a sir, yeah. Don't call me sir. Okay. I'm not teaching anything on YouTube. As such, I have a big plan that once I will financially stable, then I will sure give my experience, give my teachings to everyone. That's my aim. Okay, that's my aim. I will sure give that. Okay, but for the time being, for now, that's my short goal to become financially stable, independent financially stable. Then I can do all the things as I want. First, financial stable, financial independence is the first goal, is the main goal. Okay, so yeah, to do that we have to make consistency. We make to have productive thing. Means we have to do productive thing with consistency and thoughts. That's all I do with these kinds of streams. I did. Yeah. So yeah, if you are listening, and shut down this video and as I say, focus on your goal. That's it. You know how many hurdles are coming in my way, you don't know. I know already. I only know my loan isn't passing. I have actually no money to submit my fees. Literally no money. How I can how can I submit my fees? I don't know. I am doing just left and right. Let's stay. Let's देखते हैं क्या होगा, फीस जमा कर पाएंगे नहीं कर पाएंगे देखते हैं, अभी नहीं पता हमें, लेकिन हमारा लोन पास नहीं हुआ है. That's all I want to say. See, okay, the break time is over. निहार तेरा
Hmm.